Okay, for Newton's law of cooling, we know that we have all these pieces to this formula, and the first thing that we need to do is solve for K with the given info, and then we answer whatever question it's asking about time or temperature, etc., using that K value. So we will start with the labeling what all the pieces of the equation are. So we will start with our let's see, pleasant 72-degree Fahrenheit day. That is my ambient temperature. And the original temperature of the ice cream is 42 degrees. Then 10 minutes later, so that's my little t time, the actual temperature is 52 degrees. And so now I can find the K value. So the first question is just asking you to find K value, so you don't have to do two things. We're just doing the one thing. So I'll just fill in the pieces of this formula to solve for K. And as you can see, the K is in the exponent, so I will have to use logs. So 52 equals 72 plus my 42 minus 72 times e to the negative k times 10, 10 minutes. So I am just going to start by doing what's in the parentheses, and I'll just follow the order of operations here. And I'm going to change the negative k times 10 to negative 10k. And then I want to subtract the 72. That's a piece that often people try to add those two together, but 72 and negative 30, I'm not going to add because the negative 30 is being multiplied. So I need to just undo the 72 being added. So then I will have negative 20 equals negative 30 times e to the negative 10k. And then I'm going to divide both sides by negative 30. So that's good. I will get a positive number. It's going to be a decimal that I don't like, so I'm just going to leave it as 2/3. I can see that it would reduce to 2/3. And then I am going to use logs to rewrite this. So log base E, remember, is ln. My argument is 2/3, and my exponent is negative 10 times k. And then the last thing I'll do to solve this log is divide both sides by negative 10, or sorry, to solve for k. And so then k, remember, we're going to round to 4 decimal places. So I will say the ln of 2/3, whoops, divided by, all divided by negative 10 gives me a k of 0.0405. After the 5 is another 4, so I will keep it 0.0405. That is my k value. And then I would use that K for the next problem. So how long from a time when the ice cream was 52 degrees will it take for it to become a 60-degree puddle? So I'm going to rewrite the ATO, etc. So the ambient temperature has not changed. That is still 72 degrees. The original temperature now is 52 degrees. The new temperature is 60 degrees. The K I know because I just solved for it, 0.0405. And the little t, the time, is the thing that I do not know. And so it's going to be some number of minutes because the original t was in minutes up here. And so this K happens to tell me the cooling rate in terms of minutes. So I will go back to my original formula, and the capital T, that is 60 degrees. Ambient temperature is 72. Initial temperature now is 52 degrees minus the 72, and then times e to the negative, I went too far, 0.0405 times t, because now t is the thing that I don't know. So again, I will do what's in the parentheses first, and I will get negative 20 times all this good stuff. And then I will have to get rid of this 72, so I will subtract 72 on both sides. That will give me negative 12 equals negative 20 times e to the, all this lovely stuff. Now, my variable is in my exponent, so I'm going to have to use logs again. So I'll divide both sides by negative 20. Let's see, is that a nice number? I do know it will be positive. So 0.6, yes, that's a nice number. So 0.6 equals e to the negative 0.0405 times t. And I'm going to write that as log base e, or ln. My argument is 0.6. And my exponent goes over here. And then to get t alone, I will divide both sides by negative 0.0405. And that should give me a time that hopefully is not negative. All right, so ln 0.6 divided by negative 0.0405. Yes, so I have 12.61 minutes. So again, we always have to solve for k first. In this case, I was given the question in two parts, where the first part was just solve for k, and then you have to be careful about whether your T or your T0, your temperature or your initial temperature, has changed. Your ambient temperature did not change in this case, but any of those could change, but K will stay the same.